Good morning, everyone. Today, I would like to present my practical report on the big data introduction course, where today I will be presenting the workflow and critical implementation of our recent practical laboratory session. The main objective of this project is to build an automated data extraction pipeline, commonly known as web scraping using Python. Or specifically, we are targeting a dynamic website that sorts its data through an API that sorts its data utilizing URL parameters for pagination. The challenge here is to extract both the author names and the associated text across multiple numbers of pages in advance. We must ensure our script can navigate through this page, automatically parse the JSON data cleanly, and ultimately persist the structured data in a CSV form. So let's walk through the code. The first one in here, I have the initialization environment. Starting with the first block of our code, we focus on the environment setup and the state initialization. First, we import two crucial libraries. We import request, which is the standard Python library used to send HTTP requests to the target server, allowing us to fetch the raw data. Next, we import the pandas alias SPD. Uh, Pandas will be utilized at the very end of our pipeline to transform our semi-structured raw data into a clean tabular format. Following the import, we define our global parameters. These are the base URL pointing to the API endpoint of port2stripe.com. We also initialize list called with an empty list called result, which will act as our global container to accumulate all extracted data across all pages. Finally, we set the page num to equal 1 to ensure our script systematically begins the extraction from the very first page. Moving to the second block, or the second file, we encountered the core engine of our data pipeline. Because we do not know how many pages exist on the server, we implement a control infinite loop using a while to fragment. Inside this loop, the first thing we do is construct a dynamic URL using Python's string format. Appending our page name variable to the base URL, we then execute the HTTP GET request. To prevent our infinite loop from running endlessly or crashing due to server errors, we implemented three strict layers of automated validation. First, the HTTP status validation. We check if the response status code is not equal to 200. If an error occurs, the script prints an alert and immediately breaks the loop. Second, the content availability validation. We parse the response into GSLN format and attempt to extract the code's array. If this array returns empty, it means we have exceeded the available pages and the script safely breaks the loop. Third, the API navigation text validation. At the bottom of the loop, we check for a specific Boolean field called has Uh, if the API explicitly tells us that hasNext is false, the script knows it has reached the final page and terminates the loop. If the data passes this validation, the script enters an inner loop. Here, we iterate through every single code object. We extract their text and strip away unnecessary white spaces. We safely extract the author's name and we join the list of text into a single comma separator. This clean data is then packaged into a dictionary and appended to our global resource container. Before the repeat, we increment page number 1 to process the subsequent page. And in here we can see that the program successfully read every page from the first page until the 10th page. And then after reaching 10th page, the field has next is already false because there are no next button. Alright. And then once the automated extraction loop is complete, we move to the data inspection case. In outer cell, we use the len function on our result list. The output confirms that we have successfully gathered exactly 100 quotes in total. By slicing the first 10 items, we perform a quick sanity check to verify that our data cleaning logic works perfectly, resulting in consistent GSON, resulting in a consistent GSON structure consisting of text, author, and text. However, raw GSON is not ideal for final reporting or relational databases. Therefore, in fourth block, we utilize the pandas library by calling the pd.dataframe result. We instantly transform our list of Python dictionaries into a formal two-dimensional tabular structure. We then use the dfhead to function to reveal the top 5 rows, confirming that our columns are properly aligned and data is hardly structured. And finally, we reach the persistent stage of our lost cell. Holding the data in the computer's memory is temporary. To finalize our pipeline, we must export this data frame into a permanent physical form. We execute the df2csv function or df2csv method, assigning a hardly specified file name that includes the assignment title, still includes the text, author, and text. A critical parameter, oh sorry, assign a hard and specific file name that includes the assignment title, my student ID, and my name, and also the person that is in introduction to big data or PBD within the class that is C. And then a critical parameter we included here is index equal to false. This explicitly instructs pandas to exclude the artificial row numbering from the final CSV file, ensuring that our exported dataset remains clean and purely focused on the substantial data columns. The script then prints a success message marking the end of our extract, transform, and load or ETL process are successfully done. Well, that concludes the technical breakdowns of our automated data extraction pipeline. Thank you for your time and attention.